Okay, so now we're looking at proving lines parallel, and what we're going to use is the converse of all of our statements. And remember, the converse was if we had like P then Q, the converse was always we switch, and we would write if Q then P. So now we're going to take the converse of all of those theorems that we did with our special angles and switch them. So now we're going to use congruent angles to decide if lines are parallel. So our corresponding angles converse is going to do just that. If our corresponding angles are congruent, then we can say our lines are parallel. So this is different than before because we're starting with the piece of info that the corresponding angles are congruent. Because before we would start parallel lines, then we have congruent angles. Now we're starting congruent angles, then we have parallel lines. So now, since angle 2 and angle 6 are corresponding angles are congruent, then our lines, and we'll call them M and N, now we know that our lines M and N are parallel. So the converse is now going to be true. Same thing with our alternate interior angles. If our alternate interior angles are congruent, so we're starting congruent angles, then we can say our lines that are cut by a transversal are parallel. So if I know angle 4 is congruent to angle 5, alternate interior angles, then I know that the lines, we'll call them M and N again, are going to be parallel. Again, with alternate exterior angles, this sort of helps us remind ourselves how to identify alternate, so opposite sides of the transversal, exterior, so outside. So if our alternate exterior angles are congruent, then our lines, and in this case we've got J and K, our lines are parallel. So then I can say this guy's parallel to this guy. I would also, we can write it here, J is parallel to K. Our last piece, our same side interior, those ones weren't congruent. If our same side, I'm going to shorthand it, same side interior angles are, and in this case, supplementary, not congruent. So supplementary. Then my lines, again, are parallel. So I've got J and K. If I know that the measure of angle 3 plus the measure of angle 5 equals 180, then I know that my angles, my lines, J and K, are parallel. So I can again say J is parallel to K. So we're working backwards. That's what the converse does. And so using these theorems, we're going to find a value of x that would make M, line M, parallel to line N. Well, one of the theorems we learned is about these angles here. And from what I notice, this angle and this angle are in kind of the same position. So that means I'm looking at corresponding angles. And in order for our lines to be parallel, corresponding angles have to be congruent in order to say that our lines are parallel. So we would need 3x plus 5 to be equal to 65 in order for our lines to be parallel. So I'll solve for x. So x would need to be 20 so that our lines would be parallel. Okay, and then our last examples, the idea is basically we're still using the whole idea of alternate interior angles congruent, exterior angles congruent, same sides being supplementary. It's sort of the same process. Now we're just building off of that given information to say lines are parallel. Last two, do we have enough information to conclude that M is parallel to N? So basically the information that we would need would be corresponding angles congruent, alternate interior angles being congruent, same side interiors being supplementary, and there's one last one, alternate exterior angles being congruent. So those are the four things we would need to be able to say that our lines are parallel. Well, if I look at my first picture, this angle and this angle are not one of our special pairs, but one thing I do know is that I have a linear pair here always, right? It's like 75 plus this thing should be 180. So if I erase some things, 75 plus something will give me 180, and that something is 105. And now I'm in the situation where this angle, 105, right here, is actually corresponding angles with the angle formed by line N. So I do have corresponding angles being congruent. So I can say that M is parallel to N. So we're going to use our linear pairs and our vertical angles still. And then if we have one of our four special cases, like corresponding angles being congruent, alternate interior angles being congruent, same side interior, and exterior angles being congruent, then I can say the lines are parallel. This last one also asks about M and N being parallel. Well, M is here, N is here, and it's cut by a transversal here. What that means is I basically just ignore line S because that's probably not going to help us. So they gave us that this angle is congruent to that angle, okay. But those are, if I were to white out, let's see if that's an option here. Let's white it out. There's got to be a better way here. If I white out that line, now I know that the angles that were identified here are alternate, this guy and this guy. They're on opposite sides, so they are alternate exterior because they're on the outside. And they happen to be congruent. So if alternate exterior angles are congruent, that's one of my options. I can then say that the lines M and N are parallel.